All right, let's go over some review problems for the end of course test. All right, so the first question here is about probability. So what I want you guys to do on these problems is read the problem, pause the video, see if you can answer the question, and then come back and we'll go over the solution. So on number one, we have a fair die. That's a singular form of dice, so it's just one dice, one die. So a fair die is rolled. What is the probability that the number rolled is not an odd number and it's not an even number? Or we could say that it's not odd, nor is it a 4. All right, so pause the video, work that out, and then we'll go over the solution. All right, so hopefully you found that pretty easy. So there's 6 sides on a die, so we have our possibilities are 1, 2, 3, 4, 5, or 6. That's the only events that could happen. All right. We want the probability that it's not an odd number. So 1 would be odd, 3 would be odd, 5 would be odd. Okay. And we don't want it to be a 4. So it can't be any of those. So we have 2 possibilities that would satisfy this. So the probability that the number you roll is not odd, nor a 4, would be 1, 2 out of 6. And of course that reduces to 1/3. So a fairly easy question. All right, our second review problem. Which one of these choices is a formula for the nth term of an arithmetic sequence, of this arithmetic sequence? All right, so pause the video, work out that problem, and then we'll go over the solution. All right, so remember an arithmetic sequence is linear. So it has a slope and a y-intercept. So our common difference here, or our slope, is 3. It goes up by 3 each time. So we know right off the bat that only this and this is a possibility. So this is our slope right here in front of the variable. So only 3 in or 3 in. These are the only 2 that are going to work. But all you really have to do is just plug in some numbers and you can see what happens. So on the first one, if I plug, to get my first term, I plug in 1 for n. 9 times 1 is 9. 9 plus 3 is 12. Uh-oh, so that looks like it works, and I just told you it wouldn't work. But look what happens if we plug in a 2. So our second term, put in a 2, 9 times 2 is 18. 18 plus 3 is 21, and it doesn't work anymore. So that guy's out. All right, let's try this one. So let's put in a 1. So I get 3 times 1 is 3. 3 plus 12 is 15. I get the second term. If I put in a 2, 6 plus 12 is 18. And I get the third term. If I put in a 3, 9 plus 12 is 21. I get the fourth term. So this one is close, but it's off by 1 term. So that one's not right. It's really close, but not quite right. If you put a 0 in here, it would work. But they said that it's the first term, so this has to be the first, second, third. They didn't mention anything about a 0 term. All right, the third one. Well, we know it's not going to be right because the slope's not 3, but let's just check it. So if I put in a 1, 12 times 1 is 12. 12 plus 3 is 15. I get the second term. So we know that's not going to be right. So it's got to be this last one. Let's just check and make sure. So let's put in a 1. 3 times 1 is 3, plus 9 is 12. Got it. 3 plus 2 is 6. 6 plus 9, 15. Got it. Put in a 3. 9 plus 9 is 18. Got it. Put in a 4. 12 plus 9, 21. Got it. So this would be your correct answer. So you can always get these right. Just plug in the numbers. Plug in a few numbers. You can't just plug in 1. If you plug in 1 number and it works, that doesn't mean it's right. You got to plug in 2 or 3 numbers. Make sure they all work. So plug in a few numbers, see which formula gives you the right answer, and everybody can get that one correct. All right, so here's 2 more questions, number 3 and number 4. So the first one here, which of these functions represents the data in this table? So pause the video, work that out, see if you can come up with a solution. All right. So let's look at this data. So notice that every time I'm starting out at negative 0.2, then I'm going to 0.2, then 0.6, then 1. I'm going up by 0.4 each time. So I have a common difference here. This is a arithmetic sequence, actually. So I know this is going to be a linear function. And notice that all my choices are linear functions. They're all y equals mx plus b. So I can look at this and know my slope is 0.4. I'm going up 0.4 every time. So that's negative 0.4. I'm not going down. I'm going up. So it has to be one of these two. Notice that they give you the y-intercept. So this guy has the correct y-intercept, so I know that D is correct. That's pretty easy. You can also just plug in numbers and see if it works. So if I plug 0 in for 0.2, or if I plug 0 in for x right here, 0.2 times 0 is 0, plus 0.4, I get 0.4. That's not right, so it's out. I can try this one. I can plug 0 in for x. That's 0 plus 0.2. And it works for 0, but you have to make sure it works for at least 2 of the numbers. So put a 1 in. Negative 0.4 plus 0.2 is negative 0.2. Doesn't work anymore, so that one's out. Put in a 0 here for x, and you get a negative 0.2. It's supposed to be 0.2, so that's out. So you can always just plug in a couple of numbers, 2 or 3 numbers, to the equations they give you and see what works. So everybody should be able to get that right. All right, question number 4. Which of these properties is used to rewrite this equation as this equation? So how am I turning this first equation into this second equation? What am I doing to both sides of this equation to get this? So pause the video, see if you can answer that. All right, so what did I do to go from here to here? Well, I added 8 to both sides. Right? I did plus 8 on this side, plus 8 on that side. So which of these has anything at all to do with adding something to both sides? Obviously, it's D. But let's go through these. So the commutative property, remember, commutative property just means it's like A plus B is equal to B plus A. It just means you can do things in different orders. This has nothing to do with doing things in different orders, so it can't do that. Multiplicative inverse. Okay, that just means that, say if I have 5 over 3 and I multiply it by 3 over 5, I get 1. 3/5 is the multiplicative inverse of 5/3. So you flip it upside down. So this would be something like if you had the equation 1 over x equals 7. How would you solve that? You would multiply both sides by x, right? Or x over 1. So I multiply by the multiplicative inverse. Turn this into a 1, and then I got 7x, which I can solve from there. So this would be how you use the multiplicative inverse. All right, substitution property of equality, that's what it sounds like. If you have two things that are equal to each other, then you can make a substitution into something else. All right, so the only one that works here would be D. All right, so question number 5 is what number, when raised to the power of 1/3, equals 5? Okay, so I want to know what number you can raise to the 1/3 power and the answer be 5. So pause the video and work that out. All right, so let's just write down exactly what this says. So it asks for what number, so let's call that x. So what number can I raise to the 1/3 power and make that be equal to 5? So all I'm wanting to do is solve for x. So if you didn't set this question up right, pause the video now from where we have it set up correctly and work it out, see if you can solve it. All right, so if I want to solve for x and I raise this to the 1/3 power, what I want to do is raise both sides to the 3rd power. Okay, why do I do that? Because my exponent rule says that I can multiply these two exponents. 1/3 times 3 is 1. So I have x to the 1st power is equal to 5 to the 3rd. And of course, x to the 1st is just x. So I have x equals 5 to the third. So this is the number that I can raise to the 1/3 power and get 5. So they may give you the answer choices. It may just have 5 to the third, or it could have it worked out. So it could be x equals 125. Either one of those would be correct. All right, number 6. So solve this radical equation for x. So I have the square root of x minus 7 is equal to 3. So pause the video, solve that. All right, so this is really simple. And remember, on your test, there will be answer choices. So all you would really have to do is take each answer choice, plug it in for x, and see which one works. So it'll be extremely simple. But let's solve this one. So what I can do is square both sides of this equation. So I'm going to square this side, and I'm going to square that side. And if you square a square root, you'll just get what's left underneath there. So I have x minus 7 is equal to 9. Add 7 to both sides, and I get x equals 16. All right, so let's check and make sure that really works, because remember, on your test, you'll have answer choices, and you can just plug in each one of them, see which one works. So one of your answer choices would have been 16. So if we plug 16 in here, 16 minus 7 is 9. The square root of 9 really is 3, so that works. All right, so here's 2 more questions for you to work out. So in the first one, I'm giving you 3 complex numbers. A is equal to 5i plus 3, B is equal to negative 2i plus 1, and C is equal to 4i minus 2. I want you to find and simplify A times B minus C. So multiply these 2 and then subtract C. All right, on the second one, I want you to rewrite the cube root of 5x squared with rational exponents. All right, so pause the video, work those 2 out. All right, so let's have a go at it. So I need A times B, so that'll be 5i plus 3 times negative 2i plus 1, and I want to subtract, not equals, minus 4i minus 2. Make sure you have these parentheses around it, so minus that. All right, so let's multiply. 5i times negative 2i, that's negative 10i squared. 5i times 1 is 5i. So I'll write all this out really carefully. 3 times negative 2i is negative 6i. And 3 times 1 is plus 3. All right, and then we can simplify this. So I have negative 10i squared. 5i minus 6i, that's negative 1i, or just negative I, plus 3. All right, and then here's the key thing to remember when you're dealing with complex numbers or imaginary numbers. Remember that I squared is equal to negative 1. Okay, so extremely important. I squared is equal to negative 1 because I is equal to the square root of negative 1. All right, so I'm going to replace I squared with negative 1 minus I plus 3. All right, negative 10 times negative 1 is 10, and then 10 plus 3 is 13. So what I really have here is 13 minus I. And then don't forget to subtract the C. So let's bring this on down. I have minus 4i minus 2. All right, then subtraction is really simple, but you have to remember to distribute this minus sign to both of those. Okay, so let's come up here and write some more. I have 13. Sorry. Let's turn this around the way we write it. So it should be negative I plus 13 And then I've got minus 4i. And I've got plus 2. I'm subtracting, so I have to do minus 4i and then plus 2. The minus has to go in both those terms. All right, so I have negative I minus 4i, that's minus 5i. And I have 13 plus 2, that's 15. So there's my final answer. All right, so we want to rewrite this expression with rational exponents. So that's really easy. So I'm going to take what's underneath the radical, the 5x, and then I want to raise that to a power. It's a rational exponent, so it's going to be a fraction that I raise it to. All right, and then you only really have to remember two things. The root goes on the bottom, or the denominator of the fraction, so that's a 3. And then this exponent out here goes on the top. So it's 5x to the 2/3 power. 2/3. The root always goes in the denominator. The exponent out here always goes in the numerator. All right, now very importantly, what I've written here is not right. Okay, if I write this, then that exponent only applies to the x. It's x to the 2/3, then multiplied by 5. I want this exponent to apply to all of this, to the whole thing, to the 5x. So it's essential that you have those parentheses around it. Very essential. All right, so now this exponent applies to the whole thing, so it's 5x, all of it, raised to the 2/3 power. 2 is out here, the root is on the bottom. All right, so here's another question. I want to simplify this expression when x is not equal to 3. So why do I say that x cannot be equal to 3? Well, if x was 3, I would have a 0 on the bottom, and this expression would be undefined. So after we simplified, we'd get something that really wasn't equal to that. Okay, so don't worry too much about this, but that is an important concept. Make sure you understand that this x cannot be 3 on the bottom. If it were, you would get a 0, and this expression would be undefined. All right, so I want you to simplify this expression, and I'll give you a hint. This is going to involve long division, and then it's going to involve factoring. So give that a try. All right, so hopefully you found that one really fun and challenging. So let's divide. First of all, let's do some long division. So I want to know how many times will x minus 3 go into 5x to the 3rd plus 2x squared minus 45x minus 18. So how many times will x go into 5x to the 3rd? Well, that'll go 5x squared times. So 5x squared times x is 5x to the 3rd. 5x squared times minus 3 is minus 15x squared. And then I need to subtract all of that. So these cancel, and I have 2x squared minus negative 15x squared. So it'll be plus 15x squared plus 2x, so I get 17x squared. Bring that down. How many times will x go into 17x squared? Well, that'll go 17x times. So then multiply 17x times x is 17x squared. 17x times minus 3 is minus, let's see, 17 times 3, that's a 1, carry 2, that's 51, so minus 51x. And remember, I have to subtract all of that. So that cancels. Minus a negative, that's a plus, so I have 51x minus 45x, that'll be 6x. And bring down the minus 18. How many times will x go into 6x? Well, it'll go 6 times plus 6. 6 times x is 6x minus 18. Subtract all of that, and you get a 0, which we hoped happened. All right, so I know now that all of this can be written as, let's see where I want to write it at. All right, so anyway, so I've divided this polynomial on top by x minus 3, and it left me with this. So I can simplify all of that down to 5x squared plus 17x plus 6 because there's no remainder. So the numerator divided by x minus 3 just leaves me with that. All right, but I can factor this out. So let's factor. I need a 5x squared, so let's go with a 5x and x. I need a number here and here to multiply to get 6. Let's try 3 and 2. Check and make sure that works. It's 5x squared, 10x, 3x. That gives me 13, not 17, so that's not right. Let's switch those around. Make that a 2, a 3. Now try 5x squared, 15x, 2x, that's 17x. So I've got it. So there's my final simplified answer. As long as x is not equal to 3, this expression equals this. All right, just to make this really clear, if x were 3, this expression would be undefined because I would get a 0 on the bottom. If x were 3, this expression would be okay because I would get 15 plus 2 is 17, 3 plus 3 is 6, I would just get 17 times 6, that would be okay. So if x were 3, these would not really be equal because here it would be undefined, here it would be whatever 17 times 6 is. But as long as x is not equal to 3, this equals this. All right. Now, after we went through all that and I reminded you of long division, there's a much simpler way of doing this problem and rewrite it. So what I want you guys to do now is go back, if you didn't do this the first time, go back and try to factor the top first and factor by grouping. So factor these two, and then see what you can do to simplify that. All right, so let's try it. Okay, so I'm going to just factor these first two. So what is the greatest common factor of these two terms? Now that would be x squared. So I'm going to pull an x squared out of those two. And that will leave me with 5x plus 2. So if I distribute that back, x squared times 5x is 5x to the third. X squared times 2 is 2x squared. Okay, over here, my greatest common factor looks like a 9, because 9 will go into 45 and it'll go into 18. These are both negative, so I'm going to pull out a negative 9. So I'm going to write minus 9. And that'll leave me with 5x plus 2. Negative 9 times 5x is negative 45x. Negative 9 times 2 is negative 18. And that's all over x minus 3. Now notice that I have a 5x plus 2, 5x plus 2 in both terms, so I'm going to factor the 5x plus 2 out. That'll give me 5x plus 2 times x squared minus 9, all over x minus 3. All right, so make sure you understand that. I have a 5x plus 2, 5x plus 2 in both terms, so I factor it to the outside, and that left me with x squared minus 9. All right, x squared minus 9 will factor. You should recognize this instantly as a difference of squares. Remember, a difference of squares will factor into two conjugates. All right, so I have 5x plus 2. And then x squared minus 9 is a difference of squares. It'll factor as x plus 3 and x minus 3. All over x minus 3. All right. Now, as long as x is not equal to 3, these guys will cancel away, and I'll be left with 5x plus 2 times x plus 3. Hey, and that's the same thing we had the first time. So either way you could do this. You could do long division, or you could factor by grouping, and then factor the second part, and then cancel out the common terms. All right, here's number 10, x to the 5th equals 32. I want you to solve that for x. Now, you could probably just look at this and know what the answer is, but I want you to see how many different ways you can write the answer for x. X is equal to several different things, so go for it. All right, so just looking at this, you probably already know what the answer is. The answer is 2. 2 to the 5th is 32, so definitely x equals 32. But let's solve this systematically. So if I have x to the 5th equals 32, what would I do to solve for x? Well, I can raise both sides to the 1/5 power. So x to the 5th to the 1/5 equals 32 to the 1/5 power. So 5 times 1/5 is 1, and I'm just left with x over here. So x equals 32 to the 1/5 answer. 32 to the 1/5. All right, so this is one way you could write x. Okay, so they could give you the answer choice just written like this, 32 to the 1/5. Another way you could write it, if I raise something to the 1/5 power, the denominator of the exponent tells me the root, so this would be the 5th root of 32 to the 1st power, but we don't write that. So another way you could write the answer is the 5th root of 32. And then, of course, the 5th root of 32 is 2. X would equal 2. So any of these three could be the correct answer to this question. All right, so here's an interesting question. All right, so we have Jack that's facing a wall. Okay, so we'll call this the wall right here. Here's Jack. All right, so after 1 second, he takes a step toward the wall that covers half the distance. So he starts somewhere. After 1 second, Jack's going to cover half the distance, so he'll be right here. Then the next second, he takes a step that covers half the remaining distance. Okay, so now he's going to be here, halfway. Then he takes another step that gets him halfway closer to the wall. Then he would take another step, gets him halfway closer again to the wall, and so on. He keeps, every second, he takes a step that gets him halfway closer to the wall. All right, so which one of these graphs best represents this situation? So on each of these graphs, seconds is on the horizontal axis, and the vertical axis represents the distance remaining to the wall. So how far Jack is away from the wall. So which one of these graphs represent that situation? So pause the video and think about it. All right. So on this first graph, Jack started a certain distance from the wall, and you see that the distance keeps going down. He gets closer and closer to the wall until finally he touches the wall. It's linear. Notice he's getting close. Each second he would be getting the same distance closer to the wall. Is that what happens though? So say he starts out at 10, or let's go 12. Say he starts out at 12 feet away. After 1 second, he's at 6. And the next second, he's at 3. And the next second, he's at 1.5, and so on. So that's not linear. Okay, so it can't be that first one. All right, what about the second one? Here he starts some distance to the wall, and his distance keeps decreasing until finally he hits the wall down here. Is this what really happens though? So will Jack ever actually hit the wall? So after each second, he keeps getting a little bit closer. But I can always find a little distance in between here. So actually, if Jack does this, he's never going to get to the wall. So it can't be the second one. So what about the third one? He starts at a certain distance away, and the distance continually decreases. So notice that this looks sort of like our example. So say we put some numbers on here. We don't know these numbers, but let's just pretend. So say he starts out at 12, and then the next second, he's at 6. And then the next second, say he's at 3. And then the next second, he's at 1.5. Yeah, that's happening. And you notice that he keeps getting closer and closer to the wall, but never actually touches. So this exponential function, it's exponential, is the best representation of what's going on here. This one is just ridiculous. This one has the distance to the wall increasing. He would be going away from the wall here, so no way that could be right. So this has to be the correct answer. All right, so let's look at our final example in this video. We want to simplify this expression. So what you should do here is factor as much as you can factor, and I'll give you a hint. You should factor out a greatest common factor, and then try to factor the remaining expression. All right, so pause the video, see what you can do. All right, so let's have a look. Notice in each term, I have a 5, a 10, and a 5. So I have a greatest common factor of at least a 5, so we can pull out a 5. Notice also that I got x to the 4th, x to the 3rd, x squared. So I can pull an x squared out of it. I don't have a y in every term, so my greatest common factor would be 5x squared. All right, let's see what we have left then. So I would have x squared here. 5x squared times x squared is 5x to the 4th. Plus, here I would need a 2, an x, and a y. So 5x squared times 2xy, that's 10, x to the 3rd, y. Okay. And here, 5 goes, x squared is good, so all I would need here is a y squared. All right. Now we can factor this even further. We can factor that into 2 binomials. So here and here I'll need an x and an x. Here and here, a y and a y, plus and plus. So let's double check that. So I got x squared plus xy plus another xy, it's plus 2xy, and plus y squared. Then, notice that these are exactly the same, x plus y and x plus y, so I could write that as x plus y squared. So any of these three would be equivalent to this first expression.